All right, so we are going to just kind of sort of look at these and do them a step at a time. So hopefully you can see this pretty well. But when we get to the, what is that word? Piecewise functions, it's going to be very, very helpful for me to be able to draw on the screen. So we have what is the graph of x squared. So the question is, what does x squared look like? So before you dive in and say parabola, which it is, just remember you've got an even exponent, and so your function will be next door to each other. And then where is your variable? It's just sitting there. It's not in special brackets. It's not under in a denominator. It's not under a radical, anything like that. Okay, so I'm looking for just a parabola, which is going to be this one. So now I've got a parabola. So just to go through and look at these quickly, I would like to know what these are. So this has that slight whoop shape, so that's going to be an x to the third. Okay, this is your step function, which is going to be the hard brackets with a double vertical bar because it makes stair steps. This is going to be absolute value, which is just single vertical brackets. This one is sideways, and so that's going to be a root. So notice up here, let me change pen colors. When you go up here, this is a kind of like a vertical shape. This is a horizontal shape. So your horizontal shapes will be roots. Since this goes in opposite directions, this is going to be an odd root, so like a cubed root. This is going to be a horizontal movement, so that's going to be a root, but it goes in one direction, so he's going to be a square root. This is a line, that's your identity function. And then this one over here, which I don't know if you can see or not, because who even knows, that's a sideways parabola. That's not a function. Okay, that fails the vertical line test, so you should know right off the bat that's not it. So the next question is, what is its domain? So I would like to know how far to the left and how far to the right this thing goes. So if I am looking at my parabola, oops, sorry, that's not what I meant to do. Hang on, stop the world. Okay, if I'm looking at this parabola, then I would like to know how far to the left does it go. Well, it's going to move forever to the left. It's just going to go slowly. And it's going to move forever to the right. It's just going to go slowly. So forever left, forever right, that's your domain. Okay, so I'm just going to do a few of these. There's a bonus question because it matches. Don't know why. All right, so I've got an x cubed. I would like to choose the correct graph below. So I have an x to the odd. So I know he's going to go in opposite directions, and he'll be in quadrants 1 and 3 until next section when we start moving things. Okay, I also know he's going to be tall and skinny. He'll be more of a vertical graph than he will be horizontal. So when I'm looking for an x to the third, I know that it is, sorry, you know, there's got to be an easier way to do this. All right, I know that that's an x to the third. Okay, why can we discount b? Because it's not a function. That's a sideways parabola. That is not a function. Okay, what is c? C is your absolute value. He looks like a v. Okay, what is d? He's an x squared because he's a parabola. What is e? He's your identity function. He is y equals x. That's just a plain diagonal line. What is f? He is a both directions, but he's got some horizontal movements instead of vertical movements like this one has. So he's a root. He goes in opposite directions, so he's an odd root. And then this one is going to be your greatest integer function or the step function. And then h is kind of hard to see. Oh, look, if I can move things. Okay, so, well, I don't know what I'm doing. Here we go. That's what h looks like. I'm trying hard. Okay, so if that's what h looks like, then that's a root because it's more horizontal, and it only goes in one direction, so he is a square root. So come back up here. What is the domain of this thing that we have right here? And the domain is how far left is he going to go? Well, he's moving left. He's just doing it slowly. Okay, so this thing is moving in a leftward motion. He's just going to do it really slow. That doesn't mean that he never goes forever left. He does. He also goes forever right. So as you get up taller, he's going to be going up taller. So your domain is going to be forever left, forever right. Okay? So let's do another one. Which one is the identity function? You can do that one. Which one is the graph of a cubed root? Okay, so a cubed root. If I'm looking for a root, I want it to be more horizontal movement than vertical. And since it's an odd root, I want it to go off in both directions. So I'm looking at option A. And then, is he ever decreasing? Well, remember, for decreasing and increasing, that you read it from left to right. So right now, he's coming up this way. So he's increasing, and then he just keeps increasing. So he never decreases. He is always, always, always increasing when you read him from left to right. Okay? Hang on. So I'm trying to not move too quickly. All right, so these ones, what does this mean? This is a piecewise function, which literally means we're going to take pieces of the function. So notice I have I keep forgetting to do a screen snap. Okay, so notice first of all, I've got f of x, and that equals 3x if x is less than or equal to negative 2. And then he looks like x minus 4 if x is greater than negative 2. So we want to look at a couple of things here. Okay, we're going to look at this fact right here. And that says that f of x equals both of those things. So what we're actually going to start doing is looking as far right as possible, which goes against what we normally do. But that tells us where our restrictions are. So notice that this says to the left of negative 2, and it can also be negative 2. That says to the right of negative 2. Okay, so when I'm looking at this, and it's going to get kind of messy, sorry. When I look at this, that means I've got a coordinate plane, okay? And the change in the graphs occurs at negative 2. The change in the graph occurs at negative 2. So this one belongs to this graph. So just remember, I can just as easily write that as y equals 3x and y equals x minus 4. Math people are lazy, so I'm just going to say f of x equals both of those things, okay? So the top one is a 3x as long as x is to the left of or equal to negative 2. So 3x would look like this, okay? Your y-intercept is 0, but it has a slope of positive 3. Well, it can only look like that to the left of negative 2, so I'm going to erase it to the left of negative 2. And then he'll have a filled in circle there. Okay? What does he look like to the right of negative 2? He looks like x minus 4. So he would cross the x-axis at negative 4, or sorry, the y-axis at negative 4, and then he's going to come up this way. Okay, and he would have an open circle right here. So I'm going to redraw this stuff real quick so that you can see better what's going on, since I kind of butchered that. All right, so what I have is vertical line at negative 2, and then this is my 3x, which is going to be this top row, and then I'll just do a different color. Let's do green, and then I'm going to have, hang on, I'm looking, negative 6, negative 6. Okay, so that's going to pick up right at the same time. And it's not drawn to scale because I just drew the wrong thing. Hang on, trash. Okay, so it actually goes, oh my goodness. I just erased the whole thing. Okay. So he goes like this, and then we're going to change this to green. This is so exciting. Okay, so we're going to change that to green so it looks like this, and then we're going to put our vertical axis right here. Okay, so that's what this thing looks like. That was exciting, which means this is the green one. Okay, so my questions are, A is, what is f of negative 4? Well, where's negative 4? Because this is negative 2, this is negative 1, 0, negative 3, negative 4. So negative 4 is in the red lines territory. So I'm going to come up here to 3x, and I'm going to say 3 times negative 4 is negative 12. So at negative 4, that coordinate is negative 4, negative 12. Okay, so find out what territory you're in. So A is done. What is B? B is f of negative 2. Well, who owns the negative 2? Does the red line or does the green line own negative 2? And since this one has the or equal to, that means he gets the negative 2. Okay, so I'm going to shove a negative 2 into the red line. So 3 times negative 2 is negative 6. So right here is negative 2 comma negative 6. Okay, what about f of 0? Where is 0? 0 is right here. Well, now I'm in green lines territory. So I'm going to take the green line, which is x minus 4, and I'm going to shove in a 0, and I'm going to get a negative 4. So 0, negative 4 is on the green line. Okay, let's do 2. So here's 1 and here's 2, which I didn't draw that to scale, so I may have just screwed everything up. But let's erase this stuff. Okay, so what I have then, erase, is, hang on, I forgot. I'm at 2. So 2 belongs to the green line, so I've got x minus 4, but I'm going to do 2 minus 4 is negative 2. So this, let's just say that's negative 2. Okay, so the point 2 comma negative 2 is on the green line. And finally, what if I'm finding part E, which is f of 4? So if I'm doing part E for f of 4, where is 4? 4 is right here-ish. Okay, it's a sketch. It's not a perfect drawing. So if I grab my green line, which is x minus 4, and shove in a 4, I get a 0. Okay, so actually this right here would be 4, because the point 4 comma 0 is on the line. So basically just draw a rough sketch and then figure out where your x values are on that sketch, and then you'll know where to evaluate. Do you evaluate in the red part or in the green part? Okay, so let's try that again, because that was kind of exciting. So we have, ooh, look, it's even more fun. Okay, so starting from top to bottom, what I'm looking at is if x is less than or equal to 4. In the middle part, if x is between 4 and 8, okay? And then if x is bigger than 8. And I'm just going to look and see what each one is. And at this point, I think I'm just going to do colors, okay? And so what I have then is a coordinate plane. Let's use black. So there's my coordinate plane. If x is less than 4, so I know that I've got something going on at 4. Okay, and I got that from here. If x is between 4 and 8, so I've got something else going on at 8. And then if x is bigger than 8. So I've actually got 3 territories here. So the top territory, I'm going to say is blue, okay? So we're going to erase all this stuff. And so we're just going to say, let's do this one. You're going to be blue. So this stuff over here is blue, which means everything this direction goes in the blue line. Now notice it can also be 4. So the blue part owns that 4. Okay, so let's pick another color. We've got green, okay? So this middle part is going to be green. So if it's between 4 and 8, it's green, okay? So between 4 and 8 is green. Notice there's no equal sign, so he does not get the 4, he does not get the 8. And then what's another color we can use? We can use orange. So we've got, if x is bigger than 8, he is going to be orange. So now I just have to go through and figure out what territory I'm in. Okay, so look at f of negative 2. And I'm just going to make some of these up because you should have a different problem than I do anyway. So if I have, the first one says f of negative 2. Where's negative 2? Negative 2 is over here. I'm in blue's territory. So grab the equation, which is 1 minus 2x, and shove in a negative 2. So I get 1 minus 2 times negative 2, which becomes 1 plus 4, which is 5. Okay, so the point negative 2 comma 5 is on that blue graph. Okay, let's grab another one. What about 4? Who owns the 4? I never told you who owned the 8. Let's go back here for a second. The 8 is orange because he's equal to. Okay, so let's just grab another one. We have, I'm just making up numbers. What if we have 0? Okay, where is 0? 0 is right here. I'm in blue territory. So what I have is 1 minus 2 times 0, which is going to be 1. Okay, so the point 0 comma 1 is on that line. Okay, what about 4? Who owns the 4? Well, I already drew it in blue. Okay, so the blue owns the 4. So I'm going to do 1 minus 2 times 4. So 1 minus 8 is negative 7. So down here, I got a negative 7, which if you'll notice, that's a pretty little line. And then right here, he would have a filled in circle. So what about between 4 and 8? What happens if I tell you 5? Okay, well then that means I'm in green's territory. So 4 times 5 is going to give me 20. Holy cow, that was a mess. Okay, so 4 times 5 is going to give me 20. because I'm looking at the equation of 4x. So 4x, if I shove in a 5, I will get 20. That was really messy. Okay, so 5 comma 20 is on that graph. What happens if I use 7? Okay, 7 is in Green's territory, so 4 times 7 is 28. So he's up here. So now I've got this line going up here. So what about orange? What happens if I grab a 10? Well, what happens if I grab 8? Who owns the 8? Okay, the orange owns the 8. So let's go to that. Actually, let me just kind of sort of start over a little bit. Whiteboard. Let's try that. Okay, so if I had the 8, oh no, I've never done this before. Okay, so here's my 8. So the orange part was over here, and the 8 owned the orange, and now I forgot what the problem said. The problem said 5x plus 5. Okay, so I've got a 5x plus 5 in orange, and I'm telling you to use the 8. So the 8 belongs to the orange. So what I end up with is 45. Okay, so all the numbers bigger that way will belong to the orange equation. So that's another way that we can kind of sort of look at this and get this done. So now you just need to graph them. So let's walk through one of these. So this video is going to be a little bit longer. But let's walk through one of these and figure out what this thing looks like. So I've got a negative 2. Let me write it down. I've got f of x is, and then I've got negative 2 minus x, and I've got negative 2 plus 2x, and f is less than or equal to 1 if x is greater than 1. Okay, so what we're going to do is we're going to go to the whiteboard. Kind of nifty, okay? And I'm going to erase the whiteboard. How do I erase the whiteboard? No, that's not what I wanted to do. Go back. Go back. Okay. Create a new whiteboard. This is exciting. Okay, so here's what I have. I've got f of x equals, and then I've got a negative 2 minus x if x is less than or equal to 1, and a negative 2 plus 2x if x is greater than 1. So first of all, I'm going to rewrite this just a hair, because these are not in the proper format. So I am going to attempt to erase this one and this one, and I am going to write them in descending order. So what I have here is a negative x minus 2. So I'm just putting my x's first, and then 2x minus 2. Okay, and I'm supposed to graph this thing. So hopefully now you can see a little bit more of what this is supposed to look like, because I could put a y equals right there and right there. Remember, it's there, it's just that we're too lazy, so we put the f of x equals instead. All right, so what do I have? This is a diagonal line moving in a downwards motion. This is a diagonal line moving in an upwards motion, and they change at 1. So let's go back to black, and I know that they change at 1, so there's just like this little imaginary dotted line to tell me that that's the 1. So what do I look like to the left of 1? I look like a downwards motion line. And when I hit that 1, it's going to have a filled in circle. Okay? So that line is moving in a downwards motion because it's a negative slope. So for this one, after 1, I have a slope of 2. And so he is going to move in an upwards motion. And really, I'm just making a sketch because I don't know what's going on. So at 1, he will have an open circle, and then he'll move in an upwards direction. So I should be moving downwards with a filled in circle, then upwards with an open circle. So when I come back here, I know it's not A because he's moving up, and he should be moving down. I know it's not B because he's moving up, and he should be moving down. Okay? So I'm going to look at C, which is moving down, then moving up. And then I'm going to look at D, and D is both moving down. Okay, so let's look at C and blow him up. What I have is, oh good, Atlantic Ocean. Okay, so what I have is the change occurred at 1. So here's the 1. Okay, to the left of 1, it was a downwards line that has a filled in circle when it hits 1. And to the right of 1, it was an upwards line that has an open circle. So mine was a really horrifically rough sketch, but this is going to be your actual graph of the piecewise function. So when I look at this, at part C, I know that that is my piecewise function. So you've got a couple more to do. I don't care. Okay, so you can graph those, and you can graph that one, and you can graph that one. So just remember that this one, the bottom equation, is a parabola. Okay, your bottom equation is a parabola. All right, so I will see you in the next section. Hang on,